Hello, everyone. My name is Tianyi Zhang. I'm a postdoc at Harvard, and I work with Professor Elena Glassman. Today, I'm going to talk about enabling data-driven API design with community usage data. This work is also in collaboration with Professor Björn Hartmann from UC Berkeley and Professor Miryung from UCLA. APIs are becoming the fundamental building blocks of modern software. Nowadays, many companies and organizations provide their internal data and services through web APIs. And a larger portion of source code in software and the code we write every day contains API calls, either to functions provided by the programming language itself or functions from external libraries like TensorFlow and PyTorch. As a result, APIs are becoming one of the primary interfaces between human programmers and computers. But learning and using APIs is not an easy task. Professor Martin Robillard from McGill University did a big survey several years ago at Microsoft. In this survey, he asked Microsoft developers about their learning experiences of APIs. As pointed out by those Microsoft developers, one of the common reasons why APIs are so hard to learn is bad API design. So it's really important to keep usability in mind when building APIs, and a lot of research has been done in this direction. For example, Professor Brad Myers proposed this idea of human-centered API design, where he and his students applied many HCI methods, such as A/B testing, to build usable APIs. But it is hard to scale these methods to the number of APIs in a library. For example, Java Standard Library JDK has over 3,000 API classes, and those classes can be used together in different ways to achieve different tasks. It is extremely challenging to do a comprehensive user study for all those usage scenarios. In addition, recruiting participants is hard since users need to have adequate programming skills to use these APIs. Unlike prior work, we are looking through the lens of community-generated API usage data. Those data in online Q&A forums, code repositories, and communication channels like Slack and Gitter. We propose this idea of data-driven API design by leveraging community API usage data to inform better API design. The primary goal of this work is to investigate what kind of information API designers want to find out from the user community and what kind of tool support they need. We made the following contributions in this work. First, we did semi-structured interviews with 23 API designers. We did an in-depth analysis of their design styles, usability evaluation methods in practice, and the unmet information needs of these API designers. Finally, we proposed several tool design implications, such as mining anti-patterns in API usage and developing new methods to elicit the mental model of API users. Some of the participants in our interview study are from large tech companies, and some of them are from academia and open source communities. The company names are anonymized as requested by our participants and not shown in this slide. These participants also work on a variety of APIs. 11 of them work on libraries and frameworks such as MXNet and Caffe. 6 of them build packages and libraries to support programming languages like Julia and Chisel. And 6 of them work on web APIs. During the interview, we asked 5 main questions. The first question is really about their design experience. What kind of design decisions they have made, what they care about, and what kind of trade-offs they have made. And the second question is about the evaluation methods they use in practice. The third question is about what challenges and frustrations they have encountered during API design and evaluation. Then we want to know what kind of information they want to discover from their user communities, and also what kind of tool support they wish to have. We identified 4 types of API designers based on how users fit into their design process and how they responded to the user feedback. As the name implies, User-driven API designers always place users first. When they want to build an API or introduce some changes to their APIs, they first talk to their users. Their top concern is often the stability of their APIs. Like when they make a change to their APIs, whether this change will break user code. Self-driven designers are the opposite of user-driven designers. They often make decisions based on their own goals and the priorities. They often care more about the API expressiveness and extensibility instead of the stability of their APIs. Sometimes they may introduce abstractions to their APIs to make their APIs extensible in the future, even though those abstractions may hinder the learnability of their APIs. Visionary designers really want to be user-driven, but unfortunately, they do not have the communication channels to their users. So basically, they don't know who their users are or who will be their users. As a result, they often design based on imagined use cases rather than the real needs. During the interview, visionary designers express a strong desire to know the API usage in the wild. Finally, closed-world designers often build APIs to support other teams in the same organization. Designer team and user team often work closely with each other to decide details that suit both the designers and the users. Compared with other types of designers, closed-world designers often have the least tension with their users. Despite the differences between API designers, all the participants acknowledge the importance of keeping users in mind while building APIs. Even for self-driven API designers, though they care less about API usability, they are still curious about what users may say about their APIs and whether user needs are aligned with their own goals. When we asked how they evaluate the usability of their APIs, the majority of participants said they just wait for their users to report issues back to them through bug reports, emails, and online discussions. They also rely on their colleagues to find out design and usability issues in their APIs in peer reviews. We're surprised to see that API usability is actually in fact evaluated in such an informal and passive manner, even though APIs are playing such a significant role in software development. On the other hand, when we asked about their information needs, many API designers in our interview study, especially those visionary and user-driven API designers, expressed a strong desire to get a holistic view of real use cases of their APIs. One participant said, "I'd like to look at their code and see if they write code in the ideal way we want them to write. Because every API has its own purpose when they are being designed, and we have some use cases in mind. If not, we will probably think if the API is designed in a proper way, or we should create some more obvious APIs to deal with this case." Another thing API designers frequently mention about is to get a rich description of users' mental models. For example, they want to know what steps do API users take to learn the API, how long each step takes, and where are users stuck or give up when they are learning the API. P6 explained, "I want to get what people are thinking, not just whether they are able to use this API. Like that's what you would get from like mining GitHub repositories. But what you are not getting is like this person still spent 3 hours Googling how to use this API, and he spent another hour on Stack Overflow trying to figure out what was going on. In the end, he got that, but it was a frustrating attempt." As mentioned by this participant, this kind of information, the mental model of API user, is barely discussed in online communities. So in order to satisfy this need, we need to adapt mental model elicitation methods to gather information in the context of API usage. Also, many API designers not only care about the correct API usage, but they also wonder about common mistakes users have made when using their APIs. This is surprising to us because most API documentation and the mining techniques aim to find correct API usage patterns. But this need of common mistakes implies we need to also focus on the anti-patterns in API usage. I won't be able to go through all the other information needs due to the time reason, but if you are interested, I encourage you to read our full papers. We have a lot of examples and quotes in the paper. Finally, tool support opportunities. We summarized the 5 opportunities based on the needs of API designers. But again, for the time reason, I will only illustrate the first one, mining and visualizing API usage mistakes. Many API usage mistakes have already been documented in online Q&A forums and GitHub issue pages. It will require us to extend existing mining techniques to analyze this kind of non-code data, maybe using some NLP techniques. And we should also think about how to represent this information in a concise manner so API designers won't feel overwhelmed by this information. Even though some issues were reported online, participants suspected many user mistakes were not reported at all, which we call as undocumented learning barriers. P9 said, I think the people that use this API with no prior experience perhaps hit the wall quickly. That's a real issue. But for the most part, I suspect that I missed most of the easy problems going on there because they don't convey the first barrier with their remote communication. Participants also pointed out that compilation errors and runtime exceptions are good indicators of such undocumented learning barriers, but many of these errors are just solved from the user side and are never reported back to the designers. So it will be useful to build instrumentation tools such as at the IDE level or at the API level to gather this kind of errors. To summarize, this interview study provides good evidence to support the idea of data-driven API design. API designers really want to get a holistic view of real use cases of their APIs, but in practice, they do not have enough tool support to gather real use cases. We wish people in our research community could pursue this direction and build new interactive systems to distill different kinds of API usage insights from community data.